Okay, I'm going to do a short demonstration on how to solve a system of three equations using DESMOS. A quick reminder about simultaneous equations. So we have the simultaneous equations. We have equation 1, 2 and 3, and they each have a variable term x, y and z, as you can see here, here, here and here. So we're going to find out the answer of x, y and z for each one of these three equations, and the answer is going to be the same for each one. So the answer for x, y and z here, when you multiply everything, when you multiply and then add everything together, it's going to come up with the answer 8. Same thing here, take the same answer of x, y and z and you're going to get an answer of 8. Okay. What we need to do first is we need to pick out the coefficients being the numbers that are in front of the variables. So in this case 2, 1 and 3. So I'll quickly write down the coefficients here. The coefficients in this equation 1 are 2, 1 and 3. In the next equation the coefficients are 3, 4 and -1. And in the final one, 3, 7 and -4. If we turn this into a matrix, which happens to be a 3 by 3 matrix, we can solve the problem of our simultaneous equations by taking the matrix of the coefficients, all of these, and then multiplying them, or rather taking the inverse of them and multiplying them by the matrix that makes up the answer. So I have a matrix which is made up of the coefficients on the left hand side of the equation, here, forming a 3 by 3, and then the right hand side of the equation, the answers, forming a 3 by 1. Now to solve this, what we would then do is we would take the inverse of this matrix. If I call this one A and this one B, I take the inverse of this matrix and then I multiply it by the matrix B. I meant to use my pink pen for that. So we're going to do this in DESMOS, so I'm going to show you how. I'm just going to split my screen here. So the DESMOS tool, which is at desmos.com, can help us to solve quite a lot of problems in mathematics. If you navigate to desmos.com and then find the matrix function, you should get a screen that looks like this. And simply put, all we need to do first of all is insert a new matrix. The matrix that it starts with is a 2 by 2, so 2 rows by 2 columns. So what we're going to do is we're going to add another row and another column, making it a 3 by 3 matrix, just like we see here in my example. And then all we do is we simply use our number pad and the arrow key to move around. So the arrow key allows you to move up and down, so we follow through the process. The first equation is going to have the coefficients 2, 1 and 3. Going down to the second line, 4 and -1. Don't forget that negative. The third line, 3, 7 and -4. Taking it as a belt and braces approach, I'm going to now double check. 2, 1, 3, 3, 4, -1, 3, 7, -4. 2, 1, 3, 3, 4, -1, 3, 7, -4. So matrix A is complete and I can hit enter. I then want to start a new matrix because we need to apply both of these. So we're going to basically enter these matrices into DESMOS. So new matrix, and this is going to be 3 rows by 1 column. Basically you're making it that shape, 3 rows by 1 column. And then we enter in the answers, 8, 8 and 7. Again hitting enter, and we've now entered in the two matrices, matrix A and B, as you can see here, into our DESMOS program. the final part to find the answer for the x, y and z variables in the simultaneous linear equations is take the inverse of a. So I literally start with a, hit inverse, and then hit b. So just using this little keypad here. I've now emulated the telling the program to take the inverse of matrix A and then multiply it by B. And the answer shows up on the right hand side, which means that the value of x is equal to 2.1, y is equal to 0.7, and z is equal to 1.1. That is using DESMOS to solve a system of a 3x3 simultaneous linear equations in an order of 3. So 3 variables, 3 equations. Done.